Welcome to New Planet School. Today we are going to do a video on trigonometry. In this particular video we're going to talk about triangles, and what I mean about that, we're really going to talk about triangles. We're not going to do any equations or any math. We're really going to just try to understand what trigonometry is about, which is the study of triangles, and try to understand why that's interesting, why it's a special topic that we want to study, and how you might go about using it. Without going into any of the nitty-gritty details. We'll learn all the words, vocabulary, so that everything you do when you get down to the nitty-gritty math is very smooth and you know why you're doing what you're doing, and not get bogged down in the different terminology and words. So let's get started. So to introduce the concept of a triangle and why it's important, suppose that you and I are sitting around and we decide we want to simplify this subject of trigonometry. Say, let's do something different. Let's talk about points. What can we say about points? Well, we can say is it's a point, it's a dot on the screen. I have these dots, these are points. This one I drew a little bit bigger so you can see it. I have these points. What can I say? They're points. I have a point. Nothing I can really say. I could say where it is. It's at some position x, y, relative to some axes, some origin, but that's about all I can say. These other ones, they have different x, y's, x prime, y prime, or whatever you want to call it. And that's about all I can say, and I'd be kind of done. Not very interesting. Now, suppose I draw 2 points. This is suddenly a lot more interesting. I have a point here, I have a point here, and I'm going to draw a line between them such that everything's in a plane. What can I say about this? I can say a lot more actually, because now I have not only I have x1, y1, I now have an x2, y2. And one of the things, I have these 2 points now and I have a line between them. What could I possibly want to know about this? There's 2 things you might want to know. One is the distance between these 2 points, d. And it turns out, like I promised, no equations, but you can relate this distance to this point and this point through something called the Pythagorean theorem, which is an important part of trigonometry we'll get to later. And that's something you might want to relate it to. And the other thing, the only other possible thing you might want to relate it to is maybe you want to relate it to this angle, theta. And that's another thing that we'll learn how to do later also, but that would be about it. I have 2 points, I know where they are, and I try to relate them to the length between them and the angle. And it doesn't really matter if I have 2 points up here with a line between them. The same thing is true. I know where this one is, I know where this one is, I might try to figure out this angle, and I might try to figure out this distance. That would be it. We would learn 2 things: how to relate those positions to an angle and how to relate those positions to a distance. And once we learned that, we would be able to do pretty much any 2 lines in a plane that we wanted to do, and we would be done. So it's not all that interesting, a lot more interesting than 1 point, but not all that interesting. So let's think about now 3 points. Now this is the amazing thing about trigonometry. We draw a point, we draw another point, and we draw a line between them. That's what we just talked about, and we know that's interesting. But now we draw a 3rd point, and we draw 2 lines. Notice that something fundamentally changed here. The thing that fundamentally changes, as soon as we get to 3 points in the plane, we've now formed something called a polygon, something that didn't exist when we had only 1 or 2 points. And the polygon is a shape, covers an area in the plane. And so when you have 3, we're now talking about the concept of a shape, which didn't exist before. And it requires at least 3 sides to do that. And when we have that, it has a very special name, which of course we call a triangle. And a triangle is a shape. And so that's why 3 is very different from 1 or 2 points in the plane. It's fundamentally a different concept. Now, just because I have 3 points in the plane doesn't always mean I have a polygon or a triangle, because I could have a simple case like this where I have a straight line that goes through 3 points. Not very interesting, because this one really reduces to just 2 points with some distance between them and 2 other points with the distance between them, and it kind of reduces to 2 points in a plane. So that's not really technically a polygon or triangle. Okay, but there are other shapes. You say, why are you stopping at 3? Haven't you ever heard of a 4-sided object, or 5, 6, or 7? These are interesting. They actually also have names: squares, pentagons, hexagons, and heptagons. And of course, everybody knows what an 8-sided object looks like. And that's of course called an octagon. And I can even have more complicated shapes. Why don't I study these? Well, the answer to that question, there's two answers to that question. One is you'll get there when you get to geometry and study lots of different kinds of shapes. But the main reason is that already if you study 3, you're already studying polygons. And that's already a new concept that you probably haven't learned yet. And just understanding how to deal with shapes in math, why not just start with 3? The other thing is notice that all these shapes that you see here, they can all be reduced to triangles. And so knowing how to do triangles, suddenly, at least for these simple shapes, you're already done. You're already done. You already can do these triangles. And so it makes a lot of sense to study objects with 3 shapes because it's the first time you encounter a polygon, and a lot of other shapes can be reduced to 3-sided polygons or triangles. So it's a great place to start. And that's what the study of trigonometry is about. Okay, now, the other thing is once we've hit 3 points in the plane, suddenly there's a lot of different options here. So what we like to do is be able to categorize those. There are 3 possible ways of categorizing them. One is in terms of the corners. This turns out to be not very useful. And the reason is all triangles have 3 corners. So if you tell me I have 3 corners, I could say, that's nice, that means you have a triangle. It doesn't really convey much of an information. I could actually, if I could tell you what all the positions are, and that turns out to be a fairly cumbersome thing. And so we're going to not use that. But the other 2, the sides, are actually very, very useful. As you can see here, for example, all these sides have different lengths. Is that always true? Does it have to be true? If they're the same or different, what does that tell us about the triangle? What does it tell us about the polygon? The other thing, angles. Also a very useful concept. Notice this is a smaller angle. This is a pretty big angle. What does that tell us? Those are a very useful way to think about triangles. So it's really important to think about when people talk about triangles. They usually talk about them not in terms of where the corners are, but they typically talk about them in terms of their sides, the edges, or the angles. So let's go through both of those and see what I'm talking about. So suppose I consider a triangle with none of the sides being the same length. Okay, that is called a scalene triangle, and it typically has some very odd shape that looks like this. And notice that none of these sides have the same length. So that's a scalene triangle. Some triangles have 2 sides with the same length. And so here's an example. This has 2 sides of the same length, and this one has a different length. This has 2 sides of the same length, but different length here. And those are called isosceles. Now notice that if we're grouping by sides, notice that these 2 triangles look significantly different even though they both satisfy the definition of isosceles. And so even though we're talking about sides here, it's useful to also talk about the angles. So when we talk about angles, we'll see how these two concepts come together to be able to distinguish these 2 sorts of triangles. Now, isosceles triangles are very important. If you're going to study any triangles on this particular slide, isosceles are good because other triangles can be decomposed into these, and therefore if you know about isosceles triangle, you know a lot about other triangles. Okay, now some triangles have all sides the same length. Now if all sides are the same length, you might not be too surprised that they are called equilateral triangles, equal length. And of course they would look like this, where this length and this length and this length are the same. And what's nice about this is you obviously know other things. This angle, and this angle are all the same. So this is a very simple triangle. If you have an equilateral triangle, you're home free because you can, suddenly you just know a whole bunch of things and they're very easy to understand. Okay, now let's go to angles. Some triangles have one angle greater than 90. Those are called obtuse triangles, and they have this funny shape that looks like this, where you have an angle here that's much more than 90, or here much more than 90, and those are called obtuse triangles. You can also have triangles where all of the angles are less than 90, and they would look like this. Notice that all of these angles here, this is less than 90, less than 90, less than 90. All of these are less than 90. And that would be called an acute triangle. So there's a whole category of acute triangles. Okay. Thirdly, some triangles have one angle with 90 degrees, and those are called right triangles. Not because there are wrong triangles, but because these things have what are called in trigonometry a right angle, which uses this notation right here. Now, if you're going to learn any of the triangles on this page, I would recommend very highly you pay a lot of attention to right triangles. I've actually heard people say that trigonometry is the study of right triangles, and obviously that's not the case, because 3 points in a plane can form all these different types of triangles that I've been talking about. But what is true is that right triangles are special because a whole lot of rules are known about these types of triangles. They're very special, lots of rules. Once you know those rules, you're pretty much set with right triangles. And if you're set with right triangles, notice this. I draw a line like this. Suddenly, I have a right triangle here and a right triangle here. So if I know this, I know this. If I draw a line like this, I get a right triangle here and a right triangle here. So if I know this, I know that one. This one, I can draw a line like this. I have a right triangle here, a right triangle here, and suddenly I know about this triangle. And of course, the same would be true for this one. And so knowing right triangles is very useful. And so you spend a lot of time in trigonometry actually talking about right triangles. Okay, so let's just very quickly, I just want to make sure you understand this, this concept and the concept of the hypotenuse. So imagine we have this triangle, it has a right angle, so we put our little square down here, right here, to denote that this is a right angle. And we notice that this is a scaling right triangle. So just because we say it's a right triangle and it has a right angle doesn't tell us everything about it. Here I include the word scaling, which has to do with the lengths of the sides, not the angles. And so this one has a side here of length A, a length B that's different, and then a third length over here that's even different, and I'm going to call that H. And you're going to say, why did I choose H? A, B, C, not A, B, H. And the reason for that is right triangles are so special that the side opposite of the right angle has a very special name, and it's called the hypotenuse. And so this is a very important word to know, and it's a very important word to know what it's referring to. It's the long side that's across from the right angle. And you'll use this all the time. Even if you're not dealing with a right triangle, you might take the triangle that you're trying to solve, reduce it to a right triangle, and then use all of the interesting properties that we know about the hypotenuse. In particular, things like the Pythagorean theorem and things like this that you'll be learning about later. Again, I'm not going to go into the details or the equations here. I just want you to learn the vocabulary and see how important these concepts are. Okay, so moving along. 4 more words to learn before we wrap this up. Okay, so the first word to learn here is the altitude, and the second one is going to be the median. These are very similar concepts, but they're slightly different. So let's do the altitude first. Okay, so what we're going to do is we're going to take a point. I'll pick this one at the top because it's easiest. I'm going to draw a line that goes down here such that it makes a right angle. Now we already talked about this, that a lot of solving triangles is getting the triangle to look like a right triangle and a right triangle. So that's a very important concept. So therefore, it's so important that this line right here has a name, and it's called the altitude. And so that's an important word to learn, because if someone says, oh, draw an altitude, you know what they mean. They mean drawing this line such that you break the triangle up into 2 right triangles so that they're easier to solve. And so you hear that word altitude all the time. The other word that goes with altitude is the base. And the base refers to the side opposite the point that formed the altitude. So if I start with this point and I draw a line, imagine this is like an arrow. I'm walking along until I get to the other side and I form this right triangle. Where the side that it hits is called the base. Similarly, the point at which it hits is called the foot. So you might say something like, along the base between point A and the foot is a length D. So you might use the vocabulary in that kind of a way. And so that is what the altitude is. Very common language and useful to just have at your fingertips. Okay, now you might look at that and you might say, well, I could have drawn a line that went off this way or a line that went off that way. You know, why is this special? We see why it's special because it has to do with the right triangle. But there are other ones. Maybe they're interesting too. So let's think about that for a second. So let's clean this up and let's draw the median. And the median is same idea. I draw a line and it goes across such that this distance here and this distance here are the same. And you might ask yourself, why is that interesting? Well, it's extremely interesting because it tells you something about this triangle you probably would not have ever guessed. And it's these two things. One, if I do this, the area of this triangle here, this area, and this area over here, the blue area, turns out that A blue equals A green. Not an obvious thing, but trigonometry tells us if we draw a median, which is this line right here, and defined such that this D, this distance equals this distance D, then these two areas have to be the same. What an amazing fact. And this is one of the things that you prove in trigonometry, that this is always true, and it's clearly not obvious. So the second thing that makes medians kind of interesting is the following. So let me go across like this, and then go across and divide that one in two, and then I'm going to go across and divide the other one in two, and there I have three different medians. Now, one of the things that you probably noticed is when I drew these is that all these 3 points went through the same, all these 3 lines, sorry, went through this same point right here. And that turns out to always be true. For any triangle, if I draw 3 medians, they always go through the same point. Not obvious, but it's a rule of trigonometry that is always true. But what's amazing about this is also this. This also turns out to be what's called the center of mass of this triangle. Very interesting. Suppose I cut this out of some piece of metal or something, and I put my finger right here. Suppose that this is my finger right here. It would balance right there. And so the median tells me how to find the point at which this object will balance. And so that is always true for all triangles. And that is why the concept of the median is very interesting and important in trigonometry. So, okay, so let's move on here. Now, how can we use this information? Well, one of the ways we can use this information is in the following way. Just knowing these words can instantly tell you things and let you do things you would not have been able to do. So let's use this vocabulary. So suppose we have a triangle that looks like this. Okay, what do we know? We know it's a right triangle. We also know in this case that it's an isosceles triangle, right? And what that means, remember, is that the right triangle is telling us something about this angle, but the isosceles tells us something about the lengths, which is that this length is equal to this length. And then, of course, there's the other length over here, which I'm calling B, which we could also call that H, because technically it is the hypotenuse. You can use whatever language you want. And what we know, because we have an isosceles right triangle, is we know something right away that's very interesting. And that is this angle and this angle are the same, and they're both 45 degrees. So if I tell you isosceles and right triangle, you automatically know that. Now, how could that possibly be useful? Okay, suppose you're wandering through the desert and you come across a saguaro, and if you've never seen a saguaro up close, the first thing that you'll think to yourself is, that thing is huge. I mean, these cacti are really giant. You wouldn't want one to fall on you. The first thing you're going to think is, well, how tall is that? And you might think, well, I'll just take a tape measure and climb this thing and measure how tall it is. And then you notice all the spines on it, and you realize that's not a good idea. But you still want to know how tall it is. It's very easy given what we already know here. What we know, we're going to measure the height of this saguaro. What we do is we get out a protractor. So we have our little protractor here, and what we're going to do is we're going to get a straw, and we're going to glue it on there. And we're going to glue it on there at exactly 45 degrees. Okay? And then what we're going to do is we're going to make sure that we can look through that. Okay, so we're going to put our eye right here, and we're going to look through that particular, make sure we can look through the straw. Okay, now what we're going to do is we're going to put it down here on the ground, and we're going to look through the straw as we walk and walk and walk until we get far enough away that when we look through the straw, it exactly goes through the top. And so down here we have our eye looking through here, and it goes right to the top. And since we know, because we made it so, this is 45 degrees, and we know over here, if this is 45 degrees, and this is a right triangle, and we're assuming that the cactus, don't pick a cactus that's leaning. Therefore, we know that's a right angle. What do we know? This length equals this length. So I simply measure the distance along the ground, and lo and behold, I know what I was trying to find is the height of the cactus, and I never needed to even get very close to it. And so that's a very useful fact of isosceles right triangles. Okay, now let's review. Trigonometry is the study of triangles. What are they? They are polygons with 3 sides. And that is the new thing that trigonometry does that's not familiar with other types of math, is suddenly you're studying shapes. Very interesting part of mathematics. As simple as triangles are, there are many proofs about their properties, and I went through some of those here, but not too many, though there's another video that will be specifically on the proofs, which is sort of proving a lot of the assertions that I made in this particular video, because I didn't want to go into the math here. But what's interesting is a lot of these rules can be developed. They've been developed for thousands of years, going back to Euclid and Hipparchus and Pythagoras, and these are all well known, and you just simply need to learn them and use them. There are other polygons. Just a 3-sided polygon is not the only type, and you will get around to learning a lot more about shapes and geometry. Trigonometry is basically a way to get you interested in geometry. Sometimes trigonometry is taught sort of at the end of algebra, sometimes it's taught as part of a geometry class, and you can kind of see why. We've seen that there are many, many, many different types of triangles, and there's lots of different names for these things. They can be grouped mainly in terms of their sides or their angles. And in particular, you can imagine drawing a box like this, where we have the types of angles on this axis, and we have the types of sides on this axis. And you can imagine there's all these different types of triangles that you could draw in here. Okay, so now what you should do to make sure you all understand this is you should take this little quiz. This is an open video quiz, so take your time. Nobody's watching. Watch the video as many times as you want, but make sure that you really understand this before you move on. So what do you want to do? Make sure you understand the difference between a median and an altitude. Say it out loud. Make sure you can explain it to somebody. Why are right triangles so important? That's an important thing to get down because you'll spend a lot of time studying triangles. What's an acute triangle? And what is an example of a triangle that's not an acute triangle? Also, why don't we study objects with numbers of sides that are 1 and 2 and 4 and 5? Why do we settle on 3? Why is 3 the right thing to do? Why do we study trigonometry? Why is the median so important? And if we know properties of the median, what do we know about the triangle? What can we do with it? Okay, so also, What I want you to do is get out a piece of paper and something to write with. So get a piece of paper and a pen, and I want you to draw this diagram on the right, which we saw on the previous slide. And what I want you to do is in every empty box, I want you to draw a specific shape. Here I gave you the answer for this one. But make sure that you can go in and fill in all of these other boxes. I want you to draw a triangle that's both acute and scaling. What would that look like? What does a right isosceles triangle look like? Draw one. I want to see it. Acute equilateral. What does that look like? And if it doesn't exist, why doesn't it exist? Is it possible that some of these, it's just not possible? That's what I want you to think about. So that's your quiz. I went through it kind of quickly, but you can pause the video, come back to it, make sure you understand all of these concepts, and make absolutely sure that you can fill in this box. Okay. Now, another thing I want you to do, in addition to the quiz for this particular video, is I want you to do a project. And so this is a lot of fun. You'll really enjoy this. The first thing you need to do is to get some scissors. And then go out and find a box. And the other thing that you'll need for this project is you will need your finger. And what I want you to do is get a box, and I want you to draw on the side 3 points, and then cut it out. And then I want you to draw the 3 medians. And then cut this object out, cut this particular shape out, draw the medians, and then put your finger right here and see if it balances. And then you'll really have a good feel for how triangles work. Okay, so go get started on that. And where would you go next? Probably the next obvious video to watch from New Planet School is the unit circle. There, things are going to start to become a little bit more technical and really get deeply into how the trigonometric functions are defined. You should always go back and watch this video again after you've watched the unit circle, just to remind yourself of the names, because I won't be using too many of the names in the unit circle. So come back and watch this one again to make sure. Once you've got the unit circle down and you understand what that concept is, then watch the New Planet School video, sine, cosine, and tangent. Those are really the core functions in trigonometry. And by the time you've watched this video, done the project, done the quizzes, and watched the unit circle, you will be ready for sine, cosine, and tangent, really the heart of trigonometry. So that's what you should do next. There's your plan. Okay. And with that, I hope to see you back here at New Planet School for some other videos.